class. So the snow day has kind of thrown us off. So here I am home with my kids, and I'm going to take you through the rest of these 6-4 notes because we almost had it anyways, and that way you can complete the lab on your own. So we were on this slide right here. We're looking at the difference in the normal cosine graph versus 2 cosine 3x. So we see the main change that we learned in our last class was that 2 is changing the amplitude. So all of our maxes and mins are now at 2 and -2. And then that 3x there reduces the period. So it's 2 pi divided by 3, which means that our period is now 2/3 pi. And we see that because we can make a cycle much faster, in fact, 3 times faster than we were with the original graph. Okay, vertical shifts are what we're moving on next, and if you'll remember our order, vertical shifts always come last. So very important to remember that vertical shifts always come last. And we are seeing the original sine graph just shifted up 1 unit. So what normally was at the origin is now up here at 1, 1. And then what normally was down here at -1 is at 0. And what would normally here at 1 is now up at 2. So every point is just shifted up 1. And for the cosine graph, we moved it down 1. So it used to have this mountain here at 1, and now it's moved down 1, and the whole graph is moved every point down 1. So we see that. All right, moving on to the next slide. Okay, on the next page, we have another transformation chart that we're going to do. So I'm going to walk you through it real quick. And the first translation we see is the 2x for the horizontal. So remember, this 2 here is affecting our x's, not our y's. So I'm going to recopy the y's right down just like they are. And I am going to, remember, it does the opposite. This is the tricky one. So it does the opposite, so I'm going to divide all the x's by 2. Or times by 1/2, however you want to think about it. And this will be my result that we see there. Sorry, my daughter needed a snack apparently. Okay, in the next box there, we have a negative. That negative affects the y. So I'm going to change all the y coordinates to the opposite of what they were. The x's actually stay the same, so I'm not going to waste my time recopying them, but they would stay the same. All right, and then in our final shift here, we are moving the y values up 2. So I'm going to plus 2 to the 0. That makes it 2. Oops. And I'm going to plus 2 to the -1. I'm going to plus 2. I'm going to plus 2. And I am going to plus 2. And the x coordinates are all going to stay the same. All right, and then we see our final chart here. It's exactly what we just came up with, and we are ready to plot it. So when we plot it, I'm just gonna plot these dots real quick. 0, 2, pi over 4, 1, pi over 2, 2, 3/4 pi at 3, and then pi at 2. And we have that right there. And that takes us through 1 complete period, and it will just repeat that again. So our amplitude, that's a little bit tricky now. So don't go say the amplitude is 3 because it's up here at 3. That's not actually true. The amplitude is like half the distance from the lowest to the highest. So the amplitude is actually still 1 because our lowest point's at 1 and our highest point's at 3. And so if we split that difference, that's just 1 unit up and 1 unit down. So our amplitude is still just 1. That's a little bit tricky on that one. And see, you don't see a number there, and so that's why the amplitude is 1. And then our period is 2 pi divided by 2, which would be pi. And we can clearly see that here, that we've got 1 full cycle in pi units. So there we see those graphs. We see the original graph, and then we see that it is going to do its cycle twice as fast. It's going to reflect upside down and then shift up 2. And we see what that final translation would look like. Again, I like to break it up step at a time. I can't really get from here to here in 1 step that's hard for my little brain to think about, so I like to break it up to steps at a time and do the little charts. That definitely makes it easier for me. That may not have been the way you were taught, but that's the way I typically teach it because I feel like most students can handle that method. All right, this last little part we're gonna do is actually going backwards. Instead of giving the equation and us graphing, we're gonna take a graph and do the equation, which is kind of cool. So amplitude, we are going down from -3 to +3. That means our amplitude is 3. And then we want to decide whether it's a sine or a cosine function. That's what they're trying to get us to decide right there. Is that a sine or cosine function? Well, because it kind of has its mountain here, we would think that is a cosine function. If it was going through the origin here, that would be more of a sine. That is the sine function. All right, our period, here's our mountain. We get back to that mountain in 1 unit. So our period is 1 because it takes 1 unit to get to there. And that is not the same thing as pi, that's 1. So to find our equation, we want to look to see what that w is. We're actually going to do a little bit of solving here. This is one of the harder things left in this lesson. So the period equation is 2 pi divided by w equals the period. So we are solving for w here. So we're going to do some kind of cross multiplying here. W equals 2 pi. And there we go. So w is 2 pi. So our final equation is 3 cosine 2 pi x. And I want to double check all that, make sure that all works. Is our amplitude 3? Yes, it is. Is our period 2 pi divided by 2 pi, which is 1? Yes, it is. So that is the correct equation for this graph. All right, last little bit to over here on the back. I'm sorry I'm having to do it this way. I know it would be easier if we were in class, but enjoy the snow and still hopefully able to complete this 6.4 lesson and get our lab done. Okay, last we have our last little find the equation. So we see this graph. We see that it looks like it goes through the origin here. That's a clue that it would be a sine graph, but sine graph is supposed to come to its mountain first, and it doesn't. It comes to its valley first. And so what that means is that is a big sign that this thing is flipped, because that mountain is flipped over here and becoming the valley first, and therefore that means it's a reflection. So this is a reflection of the sine function over the x-axis. And therefore, we are going to see a negative in front of the equation. So our amplitude looks like it goes 2 to -2, so our amplitude is 2, and they want us to kind of say there, it depends on how you want to think about it. You could say A is -2 there, but you could also act like that negative is just part of the reflection, and then the amplitude is 2, so however you want to think about that. But it is a -2 in front of this equation. We realize it's a sine function. The last thing we want to do is figure out the period. The period has to clue us in on what this W is. So our period, looking up here, okay, we go from valley to mountain, 4. 4 units is our period. So if our period is 4 units, we set this equal to 2 pi over W, because that's the period equation, is that the period will be 2 pi divided by W. We do a little cross multiplying here. We solve for W, which will actually be pi over 2. So pi over 2 is what's going to go in here. I'm going to do a final last check. Is the amplitude 2? Yes, it is. Is it flipped? It is flipped. And the period should be 2 pi divided by pi over 2. And that actually does come out to be 4, which is what we're seeing in the graph. So that's our final equation. That is the end of the 6.4 notes. I really want you to finish the lab now, so I think you should have the tools to do that. So finish that lab and bring it back to me next time we meet. Thanks.